Okay, Year 8, Lesson 3. I'm just going to set a little problem first before I go into the parallel, because I know that you took on a lot last lesson. Okay, so if I've got 3 cells, all of which have got 4 volts. So 3 cells, 4 volts. What's the voltage of my battery? Well, then my battery has got a voltage of 4, 8, 12 volts. Okay, and then let's say I've got 3 light bulbs. And I put a voltmeter here. Remember, voltmeters have to be in parallel because they're measuring how much energy is there, how much energy is there. Okay, so it's measuring the difference in energy per unit charge. So that would be, well, this one gets a third of 12, well that's 4 volts, so I know that voltmeter is going to read 4 volts. Now, if I put an ammeter in here, and this ammeter says it's got 2 amps of current flowing through the circuit here. So by the time I get back to here, how much does it have here? Well, it still has 2 amps. Because if this was a hose pipe and it wasn't leaking, and I put in 2 litres here, I would still have 2 litres here. Okay, so that's the recap of series circuits from last lesson. Let's see how that's different if we're talking about a parallel circuit. Okay, so there's a reason why I'm doing this different colour, and you'll see why in a second. Okay, so that is a parallel circuit. These 2 lines are parallel to each other, just the same as we put the voltmeter in parallel across that across that light bulb. This is a parallel circuit with 2 light bulbs in it. Now, the reason why I've done it in different colours is because when you've got a parallel circuit, effectively you've got 2 circuits. So red is circuit 1, blue is circuit 2. So if you imagine cutting the wire here and here, or just one of the places, this bulb would stop working because it's no longer got a complete circuit. It goes, oh, I can't get past. But the red one will carry on working. It doesn't care about this blue one. Okay? If I cut this red one here, then the same thing happens. It can't go this way anymore, but it can still go all the way around the back. Okay? So the blue one doesn't care about the red one, so they're effectively 2 separate circuits. However, if I cut it here, I'm cutting both the red and the blue, so both of them stop working. Now, if I've got 12 volts of energy per unit charge here, then remember what we said about all of the energy has to be used up. So if I put in a voltmeter here to see how much energy is being used up per unit charge by that light bulb, well, if you look, my red circuit starts at 12 and goes to 0, so that's going to be 12 volts. And my blue one, that starts at 12 and ends up at 0. So V2, if I was to put another one in, that one equals 12 as well. And if I was to put in a third one, well, this one would also be 12 volts. Okay, so the thing to remember on this one is that the voltage is not shared anymore. The voltage is the same on each branch, and it's the total voltage from the light bulb each time. from the battery, sorry. So this, when there was one light bulb, in theory, will be just as bright as when there's two, as when there are three, because they've all got 12 volts. Now, obviously, if you're running 3 light bulbs, your battery is going to run out 3 times as fast, because your battery is now running 3 circuits. And that's how I like to think of parallel circuits, that each parallel circuit is a new circuit, and I find that really helps me to understand how parallel circuits work. Okay, so the next bit we're going to look at is how does that affect current in a circuit. Okay, so if I put an ammeter here, you can see that I've got the current for the red circuit, the blue circuit, and the green circuit. And let's say that my current there is 9 amps. And if I was to measure the current again here, well, it's going to be 9 amps again there, because I've got the red circuit, the blue circuit, and the green circuit here, and I've got the red circuit, the blue circuit, and the green circuit here. So those two places on this are the same, so they're going to have the same current of 9 amps. But if I was to put an ammeter in here, well, I've only got the red circuit now. If I was to put an ammeter in here, well, I've only got the blue circuit here now. And if I was to put an ammeter here, I've only got the green circuit. Now, if all of these light bulbs are all the same, so if they're identical, then they'll get an equal share of that current, which means that the blue one will have 3 amps, the red one will have 3 amps, and the green one will get 3 amps. Which means that it splits out 3 times and then all comes back together again at the end. So at the start point and at the end point the current will be the same, but each time it splits the current is shared. So in a parallel circuit the current is shared. Now, if I put an ammeter in here, I've got the blue and the green there. How many amps will that have? That's right, I'll have 6 amps. Okay? Because it hasn't split yet into the third split.